Hi everyone, so this video is about the trig functions, and it's a tangent function. So y equals 10x, and we're going to go through the type of the function, domain, range, period, amplitude. Okay, so please watch the sine and cosine functions as well. Now the tan function looks like this. Okay, well, I can't really fit all the whole graph here, but you get the idea. Okay, so that's a 0, that's a 90, 180, 270 and 360. I put all in the radian form, the pi form, just to get used to it. So that's a 30, 45, that's a 60. Okay, so tan 30 is 1 over root 3, tan 45 is 1, tan 60 is root 3, and I'll just put it into the decimal form so it's easier for us to recognize. Now again, this from 0 to 90 is the first quadrant, 90 to 180 is the second quadrant, and 180 to 270 is the third, and 270 is the 360 is fourth quadrant. Now with a tangent is a little bit different, isn't it? Because what is a 10x? Let's see, 10x, we can rewrite it as a sine x over cos x. Now what does that mean? It means cos x cannot be 0 simply because we cannot divide it by 0. Okay, so therefore the graph, the function, tan function, will have asymptotes where cos x equals 0. So if I sort of sketch the cos graph here, roughly, that's 1, that's minus 1, that's 90 degrees, that's 270. Yep. So when it's 90 degrees and 270 degrees, which is pi over 2 and 3 pi over 2, you will have asymptotes. Okay, and also when x equals, sine x equals 0, the tan whole thing will be 0. So if I sketch sine graph here, roughly, that's 1, that's minus 1, that's pi 180, that's 2 pi 360. So when it's a pi and 2 pi, 180 and 360, the whole thing will be an x-intercept. It'll be on the 0. So let's have a look at this, and that's what it is. So we will get the 90, 270, there's asymptotes going down. The red dotted line is asymptotes. And then x-intercept will be 0. Oh yeah, 0. We didn't talk about the 0. 0, and then pi and 2 pi. That's what x-intercept was, because sine x is 0 there. Okay, so tan is positive in a first quadrant and third quadrant, isn't it? That's a unit circle right there. So if you look at it, that's first quadrant, that's second quadrant is negative, third quadrant is positive, fourth quadrant is negative. So that makes sense. Okay, now let's have a look at its odd function or even function. So what I'm going to do, I'm just going to pick 45 degrees here. So I'm going to go tan 45 degrees equals, you know, that's 1. So that's 45 is 1. But if I put negative 45, it'd be minus 1. So tan negative 45 equals negative 1, which I can rewrite something like this. That would be the same, because that was 1, so we put a minus 1, it would be minus 1, right? So therefore, this is a classical case of odd function, because odd function is when it's f of minus x, it will be minus f of x. So we put negative there, you will get negative 1. It's the same as that. Okay, which is, well, yeah, that one, minus 1045 is same as 10 minus 45. So that's the same as that, and that's what it is. That's odd. And let's not forget even function will be x, that's even. Okay, so this tan function is odd function, and the domain will be any x values we can have. Not quite, because we got asymptotes. Okay, it can be done, but a bit of a condition applies. And range, have a look at the range. What is the range here? Range can be any, isn't it? There's no pattern that it's going to turn it direction around. It's going to go continuously go up, continuously go down. So it'll be negative infinity to positive infinity. And period. Let's have a look at the period. It's not 2 pi anymore. This is one whole pattern. Okay, same one whole pattern. That's actually pi. Okay, and then amplitude, we don't have amplitude here because it's keep continuing. Okay, so let's have a look. Type was odd function, and domain negative infinity to infinity. Range same. Okay, but except those asymptotes, yeah? So it'll be pi over 2, 3 pi over 2, dot, dot, dot. Okay, except for that, that's all good. Period, it's only pi, and no amplitude on this one. Okay, this is a tan function. And next video, we're going to do reciprocal functions.